everyone. Welcome to another episode of React Roundup. I'm your host today, Paige Niedringhaus, and we are joined by our panelists TJ Van Tol.
Hey, everybody.
And Jack Harrington.
Hello there.
And our special guest today is Giulio Zausa. Welcome, Giulio.
Yeah, nice to be here. Sorry.
Well, we're glad to have you here. So, Giulio, maybe you could tell our listeners a little bit about who you are, why you're famous, and what we'll be talking about today.
Well, yeah, I mean, famous is a big word, but yeah, I'm a software engineer. I currently work for a company called Flux, with which we are building next generation collaborative tools to design PCB printed circuit boards on the browser. And I think so. And previously I worked on other companies doing WebGL stuff, JavaScript, TypeScript. I work with React a lot. And I also collaborate with some open source projects, for example, with Poemandrous, the creators of React Spring and React Fiber. I'm one of the authors of a library called the React Flex that allows you to use flex layouts in 3D environments using THREE.js and React.
Oh,
and I've been in contact with a lot of performance delicate situation on the browser. So that's what I'm working on right now, making stuff faster, making stuff scalable. So yeah.
Well, that sounds super interesting. I'd actually love to hear more about some of the performance-intensive solutions or things that you've been encountering lately. If you could elaborate a little bit on that.
Yeah, absolutely. Especially right now in what I'm working on, this product called Flux, and we're really investing in performance because when you're building a tool that works on the browser, you really have to build something that is not your usual web application. Because normally when you talk about web application, like a website or a simpler web application, what you worry about is the time that takes for the page to load or the interaction time. And really you have different metrics compared to the ones that you have when you are actually building for example, a 3D editor on the web, because like the scale of data that you are dealing with is completely different.
Yeah, I think that's one of the things that makes web performance so hard to talk about is like it always depends, right? That's like our favorite line on the show. It depends what you're building, but like your performance tips for like, oh, I'm building something that's like a CMS or e-commerce, which is like probably the more common use case. That sort of stuff doesn't necessarily apply to everyone because like in a graphics context, like for the most part in a THREE.js environment, you're not dealing with the DOM so much, right? You're sort of in a completely separate world. So maybe for people that haven't been in that sort of environment, like what are some of like the obvious performance tips? Like if you start to venture into that world, what are some different things to think about that some of us that spend most of our time in like an e-commerce DOM-centric
some
sort
of us
way
who aspire
wouldn't
to be in 3D.
Yeah.
Wouldn't that be great?
Yeah.
Never do it.
If you think about it, like when you're building a product like an e-commerce or a blog, normally the amount of data that you have is limited. Normally, for example, you might have thousands and thousands of products that are shown in your e-commerce. But normally you fetch only a window of that in your view, and the server takes care of that. And the server is already optimized with algorithms and search to already filter data for you. Instead, when you're working with something like an editor on the web, what you do is that you necessarily need to load your entire document. Because you have to be able to, in an instant, show the entire document immediately. Imagine, for example, when you're working in Figma and you have a lot of different canvases and elements, And Figma always allow you to zoom out and see everything at once. And that's the difficult part, being able to store in memory everything and show it the second that the user requires it. That's something that you don't really need on an e-commerce website, because on e-commerce websites, sometimes you just remove your filter, wait a couple of seconds for the service to respond, and then you have the data. But yeah, and you are right when you talk about that we are not dealing much with the DOM. Well, actually we are, because if you think about it, when you're building something like we are, you both have a canvas that is just a canvas with which you are basically building every part of your UI manually. But you also have a lot of parts that are done using DOM. For example, the inspector in which you can enter or change properties, or for example, we have the tree like in Figma in which you can see all your elements and select them and search around them. And that's still DOM. But yeah, you're right when you're talking about that we will basically ejected from the DOM and we have one big canvas and we are doing everything manually.
So does it become more about memory management then? Just because, like, what are sort of the like dev toolsy things that you spend your days in looking for performance problems? Is it just like raw, like how much memory is this thing consuming? Because I imagine, like, I'm thinking PCBs, which, by the way, Paige and I work in that sort of world, so I've got a bunch of PCBs sitting around here. So I'm picturing in my head, like, you got some complicated thing that I'm like moving around and zooming. So are you like watching in dev tools, like, oh crap, how much memory am I building up? Am I like cleaning up my objects appropriately? Is that sort of, I'm just sort of curious what your like day in, day out, like performance workflow, what sort of things you're looking for? How does that work?
Yeah, and about dev tools, the things that I'm working with most is, of course, the Chrome profiler, the time profiler that allows me to see if I have something that is taking 3 seconds, what is actually doing in those 3 seconds. And the heap analyzer of Chrome that is very powerful because it allows you to take a snapshot of the heap and see both what are the objects that are taking a lot of space and also the retainers. Because you may have elements like objects in memory that are very small on their own, but maybe they are referring to some other data. They have a pointer to some other data. So those objects are the reason why you have a memory leak somewhere. And then there is another very important tool that is the React profiler that allows you to press record, do some operations, and see what is happening inside React. Because otherwise, sometimes you look at the Chrome profiler, you see a big stack trace from React, and you see commit unit of work, and all stuff like that, and you're like, what is happening inside there? Like, especially with React 18 now, with the concurrency mode enabled, it's pretty hard to understand what is going on there. And so, yeah, the Chrome profiler is pretty important. But there is a fourth tool that I had to use in some circumstances. That is the Chrome tracer. That is very little known. There is unfortunately very little documentation about it. And it's an internal tool that is available in Chrome that allows you to profile not only your current JavaScript virtual machine, but also the internals of Chrome. You know that Chrome works by segmenting your tabs into different processes. And those processes have a lot of stuff that is going on. There is not only the JavaScript virtual machine, there is also the GPU processes that is separate. There is a garbage collector, there is the compositing. And we had a bug in which we were trying to figure out why, like, the page during load spent exactly 2 minutes, I think, doing work that we had no idea what it was doing. So we had a problem that the page was stuck for 2 minutes, and we tried to profile that with the Chrome profiler. And the result was that there was a hole on those 2 minutes in which the profiler had no idea what happened. So it was a very strange situation.
That's crazy.
Yeah,
you say like 2 minutes Because can this happen like if a page goes in the background, right? Like you still need to know what's happening. Is that the sort of situation you're talking about? Or like, how does it have 2 minutes where it doesn't know what's
Yeah,
happening?
yeah, that's interesting. And the reason why that was happening was not, or the problem was not in the JavaScript process. The JavaScript process was fine. It was just waiting. The problem was in the GPU process because Chrome handles a lot of GPU stuff in a separate process. And then that process you are not really profiling it in the Chrome profiler because it's running separately. And what we discovered is that the GPU process was running and allocating a ton of memory. And at a certain point, it just crashed, and Chrome started a new instance of that process. And from that new instance, it worked perfectly. So we knew that there was a problem, that we were doing something wrong in WebGL, but we didn't know what was happening. And in Chrome, it had this behavior that it was stuck for 2 minutes and then it started working again. In Firefox, instead, you basically had to kill your Firefox instance because it would freeze up in your browser. And the cool thing is that with the Chrome tracer, we were able to profile what was happening inside the GPU process, and we saw that there was a lot of memory that was being allocated in the description for the WebGL vertex attributes. That is a very uh, it's a thing that people that work with WebGL knows. Maybe, but if you don't work with WebGL, you probably never heard of it. And so the problem was that we were literally allocating a WebGL object in a loop, whereas we should have done that once for the entire session. And it's pretty difficult in those situations because you end up with a problem, especially if you have a 300,000 lines code base in which the entire browser locks up and you're like, what is happening? You try with the
Yeah.
profiler and the profiler shows you a hole. And it's nice to know that there are tools at least to keep profiling from another point of view and still go on with your work.
Yeah.
It's interesting because I think memory debugging is something that your average web developer probably has no idea how to do because it like very rarely actually comes up. Then the only experience I have with it is when I had a stint doing native apps, because in the native world, that sort of stuff is very important, right?
Yeah.
Because it's the sort of thing a native app can absolutely doesn't want to be losing memory. And it's also interesting to hear that like you almost get into like OS level debugging tools or like at the, because I mean, at a certain point, like Chrome has some responsibility for if a rogue web app starts like using memory like crazy, Chrome's going to shut it down at some point, right? Like it's like the browser's responsibility to keep things from going out of control. So it's just sort of fascinating to hear about, I think, a different paradigm that most of us just aren't familiar with the web world.
So,
That's a problem with us. Because usually Chrome kills your app if it thinks that there's a rogue app that is consuming too much memory. But sometimes we have legitimate reason to allocate that much memory. So Chrome is constantly killing us.
Oh, no.
Is there anything you could tell Chrome? Like, can you request, like, say, like, hey, I'm a memory heavy app. Can I get more system resources? Or are you just kind of at the mercy of the browser?
So.
Okay.
Yeah, you can't.
I've seen a lot. I try to look into it a lot, but there is a lot of contradicting information about how much Chrome allows you to use RAM, and it changes from version to version, from operating system to operating system. So it's not easy to do that kind of stuff.
Mm-hmm.
Okay, so from a regular person's perspective on it, or like not regular person, but like e-commerce or whatever. So, are there unit test tools or testing tools that you apply to your app on a performance level? I'm kind of curious around, like, so you can track version to version. Makes you check that in, and oh my god, now we're
I mean, we try to do some of it. We try to start with performance testing. which is actually a cool concept in which you have your unit test that you normally, for example, you have your functions that you use for operate with data and stuff like that. And what we try to do is run those unit tests a lot of times and see how much time it takes. So we know, for example, that if we have a function that is on hot path, for example, something that happens every frame, we know that we want that function to take at most 3 milliseconds. The problem with that is that it's very dependent on a lot of stuff. It's dependent on how the garbage collector is feeling, on the destination computer, and ultimately it's not too important because if you're trying to analyze the single functions, then you maybe figure out that that function never actually mattered and that was something else that was slowing down everything completely. So actually, the way that we are tracking that right now is by doing analytics with amplitude. And so we know that this is more of a crowd-funded way of doing it. But what we try to do is either do it manually and check that for every release, everything is speedy, even with bigger projects, with bigger documents. Or we take from all the environments, the pre-release environment, the production environment, all the data that we can. We have a lot of instrumentation in the code that is constantly sending performance information, of course, anonymized. And so the moment that we have an user for which a document loading is taking more than a certain amount of seconds, we're going to fire an alert so that our team knows that there is something wrong going on there. And also, since we want to track how well we're doing with performance for each PR, we are also using other tools such as the Bugbear and, as I said, Amplitude, with which we can keep track of the average frame rate and if there are some obvious outliers there.
That's really cool.
Yeah, absolutely.
That is really interesting. So one question that I had is, are you building all of this in JavaScript or in React, or are there some other maybe closer to the Metal frameworks that you're using or programming languages to make this stuff so fast?
Yeah, most of the core code base is in TypeScript, and we of course have some modules that are written in WebAssembly, but not much for a performance reason, but because we wanted to integrate with some libraries that they were originated written in C, especially some libraries regarding the simulator and other stuff like operation on polygons. And the only reason why we're using WebAssembly there, it's because we're using libraries that originally were written in C or C++ or whatever. So we are trying to keep most of our code base in JavaScript because actually that's the closest to the metal that you can be on the web. Because of course you can switch to WebAssembly, but WebAssembly, it's something that if you don't do it right, it's going to be slower than JavaScript. And you can get very close to the metal with TypeScript already. And if you the reason why you would want to use WebAssembly is either because you want to use some libraries that you can't use in JavaScript otherwise, like a C++ one, or if you want to literally obsess over memory management. If you write in a language like C++, you can basically write your memory allocation routines, and you can, if you start allocating everything statically, then you can be, of course, much more memory efficient. But it's something that requires an entire team of people that knows how to write to C++ or Rust code, and you're going to have a very hard time debugging it. And it's not something that really you would recommend for a startup that has less than 100 employees. Because the moment that you start working in Rust or C++, you really open a Pandora box of stuff that could go wrong, and you have nobody that is able to understand what is going on there.
Yeah, that's fascinating. I like that way of thinking about it because it's in a way it's the sort of traditional trade-off, right? JavaScript, of course, if you write everything in raw C++, sure, you have the potential to write it faster, but then you have to write it in raw C++,
And you have to write it
or
faster
Rust.
because it's
Yeah.
very easy to write C++ code that is slow.
Mm-hmm.
Yes. It's interesting though, because some like Figma is sort of famously using that sort of approach at scale. But then again, like if that's sort of their niche, right? So if you come in, if you have a team that's what they know how to do, or maybe they've got some graphical tool that's written using that tech stack and wants to bring it to the web, that might be the better approach. But if your skill set is more web associated, then it seems like that would be a pretty hard path to go down.
Yeah, I mean, if you got a few people from like the Photoshop team, not that happened, but
yeah, hypothetically,
just hypothetically.
Yeah, and still Figma is using React. I know that Figma internally is using WebAssembly for the rendering engine.
Yeah.
And that was because Figma comes from another time, from basically 10 years ago, in which it was not really clear how the WebAssembly, WebGL, and everything was going to turn out. And so I think to remember that they started writing C++ because so that it would be easier for them to then pivot into a desktop app. But as I remember, they said that they would not do that again and will simply stick to JavaScript.
That's interesting.
I think that's true of a lot of things that were written even 5 years
10
ago.
years ago. Yeah.
So React is one concept we strangely haven't really got into too much. Paige kind of asked at this, but I'm curious, like, how does React fit into the equation? Like, what are you using React for? Yeah, how is it playing a part in the apps that you're building?
Yeah, good question. We really started with React when we built Flux. And so our entire UI is written in React. Originally, the schematic editor was not written using React, but like the canvas of the schematic editor. But instead, that's done with old plain THREE.js with classes. And that was written a long time ago. And instead, now our PCB editor, it's instead written using React Fiber. And so still our entire UI is with React, and our PCB editor is done with React and React Fiber, and we're constantly reevaluating if that was a good choice or not. And we're doing a lot of optimization on that, and especially because React is very nice and allows you to build like things very quickly. But of course, it has a cost, both in terms of performance and also a bit in terms of freedom. The second thing is a good thing because it restricts your freedom in a way that you know that you're going to write something that it's going to be easier to maintain in the future. But of course, it also creates some problems in the moment that you really want to optimize the performance further. And if you are not cautious enough with React, it's very easy to introduce either memory leaks or performance bottlenecks. And we worked a lot on that.
So for those of our listeners and myself who are not as familiar with React 3 Fiber, can you just give us an idea of what it is as a library and how it's useful or how it could be useful to your web app?
Yeah, absolutely. The idea behind React 3 Fiber is it's a reconciler that allows you to handle THREE.js in a declarative way using React. THREE.js is this, for going even a step further, it's a library to create 3D applications on the web, and it relies on the concept of a scene graph. It's a concept that is very similar to the DOM. Like in the DOM, you can have a box that contains another box that contains text, In the same way, in THREE.js, you can have a scene that contains a group, and this group contains a 3D model inside of it. And the logic is that you can interact with it in an imperative way, like you do with the DOM, and remove elements, add elements, append, move them. And every time that you add, for example, transformation to a node, to a parent, it will also move the children. So if you have a group with stuff inside of it and you move it on the left, everything that is inside that group, it will be moved on the left as well. And of course, that's a bit of a pain to handle because as we know, the DOM, it relies on get element by ID, append children, and managing that, like imagine that you have to manage a table manually with the DOM. It's a pain. It's much easier to just declare how your table is going to be displayed with React and have that flow and render declaratively. There is the same idea with React Fiber. Instead, in fact, it's using React under the hood. It's just a bit of adapter code that allows React to know how to mutate the scene graph of THREE.js. And the idea is that instead of instantiating a new group, adding to the scene, instantiating a 3D model, and adding it to the group, and so on, React Fiber allows you to use JSX to create your scenes in THREE.js and much more quickly develop a 3D application on the web. It also handles setting the props. Like if you set a position prop on a 3D model, it's going to call THREE.js to change the position of the object. And so it handles a lot of stuff to you, and it allows you to write a 3D application in a very fast and concise way. And the people at Poemandres, like Paul Henschel, for example, they wrote a lot of very, very cool demos that became famous around the web because they look very good and the interaction is super smooth. And then you look at the code and it's like 13 lines of code for something that seems extremely complicated. So the entire the entire ecosystem around React Fiber is pretty amazing. But what we discovered is that when you actually want to build some data-intensive application, like an editor or some very complex data visualization, you arrive at a point in which the abstraction is not the right one anymore, and you need to start working around it.
So if I'm just a novice with THREE.js, right, it sounds like React 3 Fiber is the way to go. Just use that. That's a big framework that sits on top of THREE.js and on top of, the 3GL stuff.
Yeah,
and there you go.
Depends what you're building. Because imagine that you want to that with React we are trying to reduce the amount of stuff, the amount of renders that you have.
Sure.
So you want to make sure that when you click a button, just one render happens and not your entire page renders every time. Unfortunately, when you build a complex application, that becomes a bit difficult to do with React Fiber, because React cannot run at 120 frames per second. It has necessary overhead to diff what happened and call all the render functions again. So if you're trying to do to animate something with React Fiber, you know that you are going against React, and the React is not going to be able to apply updates at 120 frames per second. And in the same way, if you have 60,000 elements to render and you try to do that with React, it will internally call your render function 60,000 times. It will compare the props and call all the use memo all 60,000 times. That is eventually will not scale enough, and you see that you need to transition from an approach that is one React component for each element of my data and move to an approach that is more I have one React component that is responsible for rendering all my data as once, unfortunately. Like we already do with virtualized list. Normally virtualized list, even in in the DOM nowadays are a single component in which you pass your data to it, and then internally it doesn't use React. It uses normal DOM and a lot of imperative mutations to do stuff really fast. That's the same approach basically that we are taking as well with our development.
Interesting.
All right, so I have a question. Oh, Paige, you go first.
Okay, well, my question was, are you able to use one of the React frameworks with this? Like, can you use Next.js or, any of the kind of now prescribed frameworks, or is it kind of a homegrown solution since you're using React and React 3 Fiber and kind of some specialized use cases?
If you're talking about React 3 Fiber in general, you're absolutely able to use frameworks. For example, I built other applications that were built on top of both Next.js and the Gatsby.js in the past. And both, what happens is that the stuff for React 3 Fiber will not be server-side or statically rendered, but it will be simply be Canvas and it will be run entirely on the client. And so it's actually very easy to integrate it. Just plop in the component and it will work immediately, I think. We also have in the Poimandres GitHub page some templates to use Next.js with it. So that's nice if you want an example about how to use it. But internally at Flux, right now we're using Create React App. We are not using a framework. And for mainly two reasons. The first reason is that we started building it a few years ago. And at that moment, like everybody was using Create React App. And it was not like right now that recently the React team said that either use a framework or you're doing something wrong.
Yeah.
And the second reason is that, And the second reason is that like even the React team said that there is 99% of the cases you won't use a framework. And we discussed about it, and probably an application like ours falls in the 1% case in which you don't need a framework. Because the reason why you use framework in your React application, think about Next or Remix, is because it gives you a lot of facilities and abstractions to work with. Routing, forms, server-side or static rendering, and all stuff like that. But in our application, we don't really have those needs. We don't have web forms extensively. We don't have a need for server-side or static rendering because it's like our application is literally a blank HTML with a lot of JavaScript running on top of it. We don't have a lot of pages in which we need to have the user jump through them and maintain cache between them. So really, our application is, I think it's more like comparable to having a virtual machine inside your tab that is running an entire operating system of sort.
Yeah, I mean, that makes perfect sense. It's much more client focused and a lot less, like you said, a lot less need for server rendering, which in that case, Create React App is a really good option because it doesn't try and do the caching and the rendering and all the stuff that most of the frameworks nowadays do. So yeah, that seems like a good use case for it.
All right, I have a question, and this is actually for the whole group, because I've heard about THREE.js in like various talks or whatever for many years at this point at conferences. It comes up on this podcast every so often, but I never have a chance to actually use the thing, right? And I think this is probably true for the lion's share of our listeners as well, because it's not like my designer comes back and says like, oh, we're going to include a 3D model or a 3D interaction on this page. It's like, it's not in the repertoire of your average sort of web person, right? So I'm wondering if anybody here has some suggestions, maybe something cool you've seen on the web. Like, what are some ways that like these sort of 3D effects could be useful for like your average website? Have you seen anything on the web? Like how this is like a very personal question. How can I start using this, right? Because it's exciting stuff, but I feel like I'm inevitably just going to keep it in the back of my head, but never be able to actually build anything with it. So I'm just looking, any suggestions, any ideas, I'm going to open the floor.
You mean use cases or
Yeah.
how to?
Yeah, just
Okay.
use cases. Like, what's something cool you've seen on the
I've
web
got one.
that
I've
uses
got one.
this?
So right around me in Oregon City is this lightsaber company. No kidding, they make lightsabers. And
Okay.
not real
I'm listening.
lightsabers, obviously.
I'm listening.
But you go onto their site and they've got like a builder, and then you can like kind of snap together all the pieces, and then you can actually, it renders it on the fly for you, and you can kind of spin it around, and you can see what the hilt's going to look like and what the saber, and it's really cool, honestly.
Okay.
And it's
Okay.
hard to visualize that in 2D, as a customer, right? And so I think it probably really helps their sales that they are able to do that.
I wonder, could you use this to show just like a product off? Because I'm thinking standard
Totally.
e-commerce, like, right, I'm buying a shoe. Well, it's like, well, I'm looking at static images of shoes, but what if my shoe was there in 3D and I could spin it around and maybe change the color of the shoe?
I can 100% tell you that Nike, I'm sorry, some company in the Pacific Northwest that makes shoes has this exact thing. And yes, it does. It particularly when it's a shoe that you really hyper customize, if you can get your own logo on it, or you can get your own, yes, it's very, very good for that.
I think that's one use case in which using 3D experience on the web really shines. I also did a lot of research about this in a company in which I worked previously, because in e-commerce it has really a lot of potential, especially because you can give your company superpowers with stuff like showing customized products. If you see among the React Tree Fiber examples, we have an example in which there is the floating shoe, as we were talking before, with a color picker, with which you can already see how the shoe is going to look, and also even stuff like imagine that you are a company and you're building a product. Like a physical product, and you still haven't finished your product, but you want to already show it off. You want to show it to customer. You create a 3D model of it and you put it on your website. Like even for a car, you can do that, and maybe put it even in context of like you're creating an SUV and you put it in context of the wilderness and driving inside a forest, something like that. There are really cool things that you can do. I think that the bottlenecks there are two. One is the creation of 3D model. Of course, imagine if you have a very big e-commerce and you want to start building a 3D model for every single product that you sell. That is, if you want high quality 3D models, those are unfortunately not easy to do. And the second bottleneck is that you may be worried that your product is not looking good enough, because if you want your product to look good, you really have to maybe have a bit of graphics processing power or artists that really know how to show it off. Normally, the 3D models look way better if they have ray tracing, but of course that's not something that you can do on a phone. There are a lot of ways of bake that though. There are a lot of tools that allows you to create a 3D model that is actually simpler. It's pretty simple on the hardware, but it has all the ray tracing already drawn on the textures, so that it already looks good even with lower end hardwares. But of course, that's a thing that really you have to do case by case for your products, and you have to have artists that are capable of doing that.
Yeah. You can also do the thing where you take frames, right? And you actually render on a serious GPU and you pre-render frames or a movie, and then you just put that on, you can spin it around, and it works on low-end hardware.
Yeah, and in fact, an interesting thing I think is that the famous fruit company that makes computers, and for their website, I think that they're not using any 3D model, but they're using sequences of JPGs and with alpha channels, so that what you're seeing is not a 3D model, but it's pre-rendered stuff. Of course, that's a bit defeats the purpose. So I think that really the value of having 3D on the web is when you have interactivity, like being able to customize your product or even more complicated stuff.
Yeah, I'm on a nameless swoop shoe company in their website, and I'm customizing some shoes right now. And I got to say, it's kind of fun. It's kind of cool.
Oh
to
yeah,
do. It's
and you get an emotional attachment to it, and
yeah,
you're gonna buy those shoes, man. I'm telling you, I know it.
I think also too, like I definitely see the challenge if you're like big e-commerce and I have tons of products. Like, yeah, that's a huge challenge, but there's a lot of companies where like they have one product they sell maybe, or like a small portfolio. And I'm sure there's, even if you struggle with the 3D modeling, I'm sure there are design firms out there that say like, hey, ship us your stuff and we can create high quality assets for you that you can use and like bake into your website. So it's definitely something you can find a way to get it done. So it's an interesting idea. Giving me some ideas.
So,
Paige, you got any idea?
Well, I mean, I'm thinking of car companies, and I think that I've even seen this on some websites, is where you can design, you build your car and then you can turn it around. You can look at every angle of it or close to it. Maybe it's like, 90 degrees, 45 degrees, and they just kind of rotate it that way. But that would be a cool use case for it. But I'm wondering, like, if you are new to this or you haven't used it before, what are your recommendations for getting started? Because we're obviously not going to start by building customized shoes and cars and things like that. So what's an easy way to get into it?
Well, actually, I don't agree with you because building customizable shoe or car, it's one of the simplest thing that you can do. Like programming wise, 3D modeling wise, absolutely not, because of course, building a shoe or a car 3D model is not trivial. But then what it boils down to, if you want to simply change the color of a shoe, is rendering the shoe and taking the material that is the one that you want to change the color of and setting the color value. So I think that is actually a good Hello World project for someone that starts. So if somebody wants to start doing it, I think that is very cool. It's very cool to just simply go into the React Fiber website and look at the examples. And we have a lot of cool stuff that is like very simple to do in 100 lines of code, and then you can already get started and see how you can integrate 3D experiences on your website. And there are a lot of very other cool experiences as well. Like, for example, there is one that is like picking your seat, your sitting place on a train or on an airplane. Imagine being able to see in 3D your train or your airplane and being able to click on the position that you're going to be on. Or for a cinema, that would be amazing. Imagine like giving the users the ability to see a preview of what they will see from their from the movie seat and how it will affect their possibility of viewing the movie.
A stadium too. I could totally see that.
For sure.
Like that's
you don't want to be behind a big post.
Oh man, and 2D models of stadiums always make it so hard because you're just looking at this massive thing and you're like, you have no concept of like this cheap seat up top. What am I actually going to be able to see? Like, you have no idea. So it's really interesting ideas.
Yeah, and React Fiber for building stuff like that is very amazing because it provides you an abstraction that, as we discovered, it's not really going to work if you want to render 100,000 elements and changing them constantly like we're doing at Flux. But if you want to build an experience that it's not too big, it's self-contained, and it will look really good, it really provides you with an amazing ecosystem of libraries and already made materials and controls, interaction, and everything. And yeah, check it out.
Well, cool. I'm going to have to give those React 3 Fiber examples a try. That sounds really fun. TJ, I'm excited to see what you build with it too.
Well, I'm busy right now customizing my lightsaber based off what Jax sent. So,
Oh, well, Giulio,
I go to Comic-Cons and they never. Sorry.
Well, Giulio, this has been great. Is there anything that we haven't touched on yet that you think we should talk about or we should know about?
No, I think that like regarding THREE.js and performance, there would be really hours to talk about that. But yeah, I think that's a really great introduction.
Cool. And I'm going to check out Chrome Tracer as well, because that's something that I've never heard of, but it sounds really useful for figuring out why my computer's lagging.
Yeah.
All right. Well, I think that this is the portion of the show where we move into picks, and this can be websites that you've found that are interesting, products that you like that you think our listeners would be interested in, or shows that you're watching. So, TJ, would you like to kick us off today?
Sure. I'm going to pick the show Poker Face, which is on Peacock and is pretty new. It's like a whodunit detective type style, and the creator said that it was heavily inspired by Columbo. So if you've ever watched Columbo back in the day, which is a show I used to watch with my dad all the time. So some of it is just like nostalgia for that. But the whole premise of it is they show you the crime like to start the episode. So it's not like you're not like trying to figure out who did it, but you're rather going through the eyes of the person trying to figure out how it happened. So it's kind of a unique concept. I'm 3 episodes in and I've had fun with it so far. So if you like those sort of detective-y style shows, it's a pretty good one.
Nice. And the name of it is what again?
Poker Face. Poker
Face.
Yeah, I like the actress. Like she was in some other one, and she's got this great vibe.
She was in the like Groundhog Day type show. That was really good? I can't remember the name of it though.
Yeah,
I'll have to look it up. The other thing about the show too is that her shtick is that she can tell when people are lying. That's like the whole vibe behind the show. So obviously that's how she ends up figuring out these crimes, is she can tell when people are lying about it.
Nice. That's a good superpower to have. All right. Jack, what have you got for us this week?
Sure. So speaking of PManders, and actually Daishi Kato, Daishi just released Jotai version 2, which is an atomic-based state manager. Similar to like Recoil, or I think there's one other one that's also atomic-based. It's very cool. You can basically take data, atoms, and kind of have them depend on each other. And this new V2 really cleans up the interface even more than it was. I mean, I think it always was better than Recoil, and now it's even better than Recoil. And it also brings in a vanilla aspect that that Recoil's never had, but this other, I can't remember right offhand what the other one is called, but it had. And so now you can use the same atoms with not only just React, but also in the vanilla case as well, other frameworks. It's great. Just a lot of great improvements, and it's great to see Jotai kind of picking up traction like that, because I think it's a great data model.
Very cool. Yeah, it's always exciting when things, go to their next iteration and become even more useful than they were. You didn't think they could get better, and they do.
Yeah, Daishi's doing great work, honestly.
Nice. Shout out to him. So my pick for this week is going to be a tool that I've been using quite a bit lately, which is called the Open API Generator. And at the company that I work for, we're in the process of creating our own JavaScript library to make one of our APIs easier to use in JavaScript-based projects. And the tool Open API Generator is able to take the Open API spec and generate an entire JavaScript-based library out of just that spec. So it made all the models, it made all the API endpoints, it provided documentation and examples of how to actually implement the JavaScript library. It's so cool that it was able to just do all of that with a few simple commands from the command line. So if you need to build some sort of a library like that and you have an open API spec that you're using for your API, definitely check this out because it saved us a ton of work, a ton of time, a ton of having to do it manually. And it was so shockingly easy that I was really pleasantly surprised by it. So that will be my recommendation for this week. And Giulio, do you have a recommendation for our listeners?
Yeah, I mean, I'll be that kind of nerd. And my recommendation of this week is probably something that you will find cool but completely useless. And it's a library called V86. And the idea behind it is that it's able to emulate an entire computer, an Intel x86 computer on a browser. And so, like, you can simply import the library. I've recently published on npm version that you can use with a package manager and a bundler. And you fire up the library. You load you give it the image file for the hard drive, and it will simply be able to load something like Linux or even Windows XP, and it will completely run on your browser. And with it, I was trying to do some strange stuff because I'm fascinated with old computer and technologies and retro computing. And I was trying to build a library that allows you to use React to build user interfaces inside of Windows 98, like to give it that retro style, but not just CSS that makes it look like, but it actually sends command to the virtual machine and creates UI elements. It's completely useless, but it's cool.
I love it.
That sounds fun. Nice. Very nice. Awesome. So, Giulio, if people want to get in touch with you, what's the best way to reach you online?
Well, yeah, I have Twitter. You can find me at Giulio Zausa, or I have GitHub. I think there is my email there. Or yeah, Twitter is probably the best option. So yeah.
Fantastic. Well, thank you again for joining us today and talking to us about React 3 Fiber and Flux and all the cool stuff that's available. It's been really fun having you.
Thank you for having me. It has been a pleasure.
Yeah, it was great. See you next week.
Yeah. See you on the next episode.